All right, so I've got the two end plates, which will sit like this, printed out. Now I just need to make the backing out of acrylic, and I've decided, you see how long this guy is? The longer you make the center shaft, the more the more it won't, the more instability it will have. So I've made this considerably shorter. And here's the 6 millimeter shaft, which fits perfectly inside the center hole. It's a very, very snug fit. I had to actually hit it in there. And now I will put magnets on the end here, and I have little ball bearings that I can attach there to use as it presses up against the glass back plate. But I don't think I'll need to put, actually, I don't think I'll need to put a brass rod in there, but I think I will anyway, just to make it more stable. So this is what it looks like without the sheath, but the sheath is for protection. And besides, I wanted it to be encased in copper and didn't have a copper tube to use, so I just used copper infused PLA. But this will work really good. So now what I need to do is I need to put that off to the side someplace careful. I'm thinking about using the same base I have here. I did order another 3/8 by 12 by 24 inch piece of acrylic, so that I don't have to take this guy apart. But it won't be here until tomorrow, which really bums me out because I wanted to get working on this today. But what I will need to do is, yeah, I can probably make the backings. I'm thinking about printing out a 5 millimeter backing to go on the back of this, and then continue with the acrylic. And for no other reason than I think it would look cool because I've got this new red PLA I want to use. But yeah, this guy will sit just like that, and so forth and so on. So let me move this out of the way and probably start making the backings here. Yeah, stay tuned. So really quick, my first idea, remember I had bought this this copper sheeting, this really thin stuff. I was going to try to carefully put it around the rotor, not this one, but the other rotor, the smaller one, but it would end up having a seam as it went around. But I nixed that idea. What the hell am I talking about? I nixed that idea in favor of the copper PLA. And if you notice, these magnets in here are awfully small. When you look at Sky's, he's got a much bigger rotor magnet in there. It'll be harder to get it in there, but once it's in place, it should be much more stable. This guy has a lot of flex, as you can see. I mean, it still works okay, but I've got newer magnets on the way, bigger ones. I think I've got 1/2 inch magnets. I'm not sure what those are, but if they're not big enough, I'm going to get bigger ones. Anyway, stay tuned. So it turns out I don't have enough acrylic. I'll have to wait for it to come in. So I decided to revisit this guy. This is the one with the magnetic levitation in the vertical sense. So I've got two opposing magnets right here. And what I want to do is I want to try the hall sensor with this and see how it works. Doing the same setup using this coil, I'd have to raise it up, and putting the hall sensor right there in the center, because yeah, I want to see if it doesn't get the sensor hot. So let me get it set up and we'll get this guy going. This thing spins beautifully. It's got a huge flywheel effect. So stay tuned. And I think I'm going to try it on a couple of the other motors I have. Those are all the different motors. I don't know if you can see them all. Remember that little guy there? And I have some on this table here, but this table is a mess. But I want to try the hall sensor on that. And it's funny because back in the day, I would have reused this acrylic for a new project instead of keeping it. But a lot of work went into making this. And so I really like this too. So I don't want to tear it apart and ruin it because, again, a lot of work went into it. Of course, this isn't 3D printed, but all the braces and the holders and the spacers and the bearing caps and the bearing holders, they're all 3D printed, including the coil housing. So let me get this guy set up with the hall sensor, and then I'll introduce you to two of the new toys I have from Mr. Sky. They're really nice. I'm not 100% sure how to use them, but I'll figure it out. Stay tuned. All right, so really quick. So he sent me two. This one is strictly for testing and not running anything, although you could. It's got a back EMF output, 12-volt input, and here's the coil. But this is the new, this is really nice. And this is based on the, I believe it's the 555 chip. But this one here even has a little LCD video, an LCD output. But it has the hall sensor. It has two back EMF outputs, which I can toggle on and off with this switch here. So I can have both of them running or just one of them running. I can't wait to get this one into use and see what kind of output. I don't know if it's the current or the voltage, or I can do both. I'm not really sure. I'll have to hook it up and see. But this one is really intense. Big ass capacitor, a little small ceramic capacitor, another chip. I don't know what chip that is. But yeah, this one's really nice. So I'll use this one to test and then this one to run, because that's what he kind of told me it was for. But that's really nice, huh? Can't wait to get them running. Stay tuned. So I'm making a couple of, with the little bit of acrylic that I have, I think this is 1/2-inch pieces. I'm making a couple of spacers, if you will, or support platforms. And in my research, I thought I'd just share this with you. In my research, these types of files, these diamond grit files, are the best thing for doing 3D printing and acrylic. And then after you work your way down the grits, you end up with a really nice looking piece if you take your time. Let me see if I can show you. Stay tuned. See, look at that. Isn't that beautiful? No, I'm kidding. That's the polished side when it comes to me brand new. But I can get it pretty close to this, so stay tuned. Let me show you what the other side looked like. So the other side looks like this. Obviously, it's got saw marks. So let me see how nicely I can get it. Stay tuned. With this type of file, this diamond encrusted or diamond infused file, you can really get the saw marks out, and then you have to work down to the grit. So let me see how well I can get it. Now, I tried an experiment because I had heard for certain types of plastic, I don't think acrylic is one of them. It might be, I'll try it again, that once you get it down really well and you get it polished with some 1500 grit sandpaper, you can then take a flame and go over it really quick. And that should give it that shine that I showed you on the factory side. But I've tried it with this type of acrylic and it didn't work, but I might not have gotten it down fine enough. So hold tight. So that's not bad with just a few minutes of work. There's still some scratches on there, but it's really smooth. I can feel the scratches. So I'd have to go down with the intermediate sandpaper a little bit more, but it's a far cry from that or that. But I'm just not patient enough. I'm just not patient enough. And for something like this, I really don't need it. But I wanted to kind of show you that these files, I've got several of them. They're really good for 3D prints because a regular file on a 3D printer or a 3D printed parts just melts it or smears it over. This seems to work a lot better. And the same thing with acrylic. I found out that if you use a regular file on acrylic, you basically just melt it. But with the diamond infused or diamond coated, it works really good. So let me see if I can get these scratches out, and then I'll try that flame test. Hold tight. That came out really nice. I should take the time to do that for all at least the pieces that are going to be seen. But that is really nice. And that's done with this file, which is a medium file. This, I believe, is 120 down to about 240 and then 1500. And it really didn't take that long. Now what I'm going to try is I'm going to try the flame test. Here, hold on. I'll bring you along with me on that one. I got to go get it. So I got this Bohemian. Let me see. So let's try it. Oh, yeah. Yeah. I think it's the same thing that with not using the flame. And then maybe if I bone it or take something like a piece of wood or something and then go like that. Yeah, actually it's good enough without the flame. I think the flame might have even dulled it a little bit. But yeah, I just wanted to show you that little behind the scenes when I work with acrylic. Diamond coated file, different levels of sandpaper, can take it from this, which is all nothing but saw marks, to this, which is not too bad. Stay tuned. So I figured out a couple of things. The JL94 circuit that was running this light that wouldn't work, the light is bad. I can fix it because when I tap it, it comes on. But yeah, as you can see, the test unit works really well with this. And I'm kind of surprised because this is switching really fast. Because it's a hall sensor, so it's only switching on the south. But yeah, so that's pulsating on the camera, but in real life, it's almost a solid light. Yeah, it's continually speeding up. I don't know how fast it'll go. It starts out really slow because it has that huge weight, that flywheel effect, but it's going faster and faster and faster. I really like this motor. But yeah, so Sky, the test unit works really, really well. And you can see the neon bulbs aren't firing because of the back EMF. If I were to unhook this, the neon bulbs will fire. But then I hook that back, and now the back EMF is going off. So this is 127 volt, 50 hertz light. And again, like I said, it's on the camera, it shows that flickering, but in real life, it flickers, but it's almost constantly on. But this is starting to really speed up. Yeah, it's going fast. It started out really slow. And again, I think that's because of the flywheel effect, because it's so heavy. And the chip is nice and cool, which is excellent. Yeah, all the chips on the board are cool. So, Sky, the test unit works great. The back EMF produces, and it's going even faster now. And I guess what I was doing wrong was where I was putting the Hall sensor on all my other motors, because it would heat up. It's starting to really fly now. Getting a little nervous. I should probably... I mean, I don't think these magnets are going to go anywhere. But now the light for me is solid. But again, on the camera, it's flickering much faster. But for me, it's a solid color. Sweet, 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 sweet. All right. So yeah, I'm doing this for a couple of reasons. One, I wanted to test the light. And I can fix this guy because, like I said, when I hit it, it lights up. And two, I wanted to do something while I'm waiting for the acrylic to come in. It's going even faster now. Where's my, let me see if I can, while I got you guys on camera, let me see if I can figure out what speed it's going. It's not going to be going too fast because of the, yeah, it's only doing 600 RPM. Oop, yeah, 600 RPM. 625, 627, 628. It is going up though. I suppose if I left it here for a long time. Oops. 639, 640. 500. Yeah, so it's continually going up. It's spinning fast enough for me. I wonder if I could do it on the shaft. No, there's nothing on there. 600. Yeah, this is now a solid light. It's really weird how the camera picks it up. Yeah, and the circuit's nice and cool. Yeah, it's really starting to fly. Here, let me see. 689, 690, 695, 696, 698. Come on, come on, come on. Uh-oh, what happened? 700. Come on. Catch, you bastard. Ah, it's not catching. Anyway, you can hear it. Oh, even on camera now it's starting to... You can hear it speeding up. It's actually really flying. I don't even know if this tachometer is actually accurate, because that seems like it's going faster than 700. Let me see. 750. I guess for a huge mass like that, that is a lot. And that's at 12.5 volts, pulling 180 milliamps. And it's continuing to speed up. 768, 769, 770. Yeah, I suppose if I just kept it going, now it's a solid white light for me. And it does pulsate for you guys. But yeah, so this is the test unit. And putting the Hall sensor in the middle of the coil. Obviously, these are extremely powerful magnets, so anywhere in the middle of that coil would have worked. I just happened to put it close to it. But if I put it on the edge here, it would probably still work. Speeding up. 800. Think I'll crack 1,000? I think I will. And these are ceramic bearings. And I think he said this was a 555 timer chip. I'm not really sure. I'll have to ask him. I think I know how the circuit works, but I'm not entirely sure. Got a diode over here for the output. I think it might be maxing out. 829, 830, 832, 833, 834. Oops. 840, 841, 842. Yeah, so it's starting to, I think it's starting to max out. I might get up to 900. So the light, like I said, for me is completely solid. Coil's nice and cool. The chip is absolutely cool. Oh, I love it. I love it. I finally learned how to use a hall sensor. I can't wait to try the other circuit. But that is one beastie motor. I forgot what I called this one. This one wasn't the beast. That one was the beast. This one is just the monster rotor. Yeah, this is... So all these circuits are good. It's just this freaking light bulb is bad. So I need to figure out how to fix that. I think I can pop the lens off, and there's probably just a loose connection in there because, like I said, when I hit it, it lights up. Here, let's see if we got any more going over here. 873, 874, 875, 876, 877. I think we will get up to 1,000. I'm not going to do it because it'll take forever, and you guys are probably already bored to tears watching this. But that's a beautiful circuit, Sky. Thank you. Thank you, thank you, thank you. I can't wait to try the other one. So when the acrylic comes in, I will be yada yada yada. I will be building out the new maglev. You know what I could do with this while I got it running and everything stays cool is I could charge up the capacitors I have. That bank of what is it? Those freaking super capacitors that are farads, not microfarads, but I think it's 500 farads each, which is incredibly large. It's not, that's not usual. Let's see what we got here. Oh, 898. Little Zen moment. 900. At this rate, I will crack 1,000, I think. And again, for the size of this rotor and the weight of it, that is a lot. If it was really thin and skinny like the maglevs, that'd be different. Oh, you know what? I forgot that I have that other maglev over there. Oh, and that's actually already set up with the perfect width. See that maglev over there with the orange? That would be perfect for the new rotor. But I want to make a new one. 912, 914, 913, 914, 915. Come on. 916. I think that's it. I don't think it's going to hit 1,000. But anyway, I wanted to test out the test circuit, and it's working freaking great. And I wanted to give this guy a spin up. All right, guys, until next time. Ciao. Thanks for watching. So really quick, I took apart the thing, but it was so cramped in there that the LED portion broke off. but the LEDs still work. The the neon bulbs that protect the circuit are not firing, and for you it's blinking, but for me it's solid. So this must be the driver circuit. So if I can get it out, I know I can hook it up. Just wanted to show that really quick. Ciao. And really quick, I made an error. It's 127 volt, 60 hertz. Typical um, AC light. Not typical, but yeah, 127 volts, 60 hertz. I don't know why 127. Now, again, this came from a different country, so that may be what they run over there. I don't know. But anyway, I could fix it and I will fix it. It's just going to take a little bit of finagling. I think I'm going to have to actually cut the two wires in there so that I can get the driver circuit out, resolder everything, put it back together, I'll make longer wires so that I can actually solder them to the driver circuit, because literally there's like a half an inch of wire from these terminals to the actual driver circuit. Doesn't really need it though. You saw how it was working, but I think the driver circuit will protect the LEDs. I think if I continuously run them without the circuit, I'm actually surprised they ran at all, just through straight, no circuit in between, just right off the back EMF. Anyway, now I'm finally going to say goodbye. Ciao.